Hello guys, welcome back to Mezone African Motives. Still working on Mechanotechnics and 5 revisions. In this case, we shall be working on the epicyclic gears so that we just know some basic calculations that you might be given, how to attempt typical questions that you'll be given. So this is August 2023 exam that we are going to consider. The first part on question 8 was 8.1. Name one component of epicyclic gears. So they just need one component, only one. But we know that there are so many components that we have on our epicyclic gear. We've got 4 components, meaning to say we are talking about the gears that are being involved in this case. Remember, we have got the sun gear in this case. We also have the planetary gear. We've got the planetary gear in this case. All right, that's the planetary gear in this case. We also talk about the ring gear. So this planetary gear is also referred to as the pinion in this case. So this is the pinion. All right. Then we talk about the ring gear, which is the outer part, which is the ring gear in this case. So we've got the ring gear, which is the outer part that we have, or we refer this one as the annulus. So we are referring as the annulus gear. All right, so these are the major gears that you're going to have, and also talking about the arm of that gear. And we have got this part that combines everything, which is the arm in this case. All right, so these are the components that we are supposed to be referring, any one of these. All right, any one of these. Then we move on to question 8.2. All right, this is the major part that most of us we been wanting to understand what is happening here. All right, so no problem. Let me refer this question as it is here. We are given, in this case, our epicyclic gear, and also there is another external gear that we have, which is the gear A in this case, that we are just a normal gear in this case. All right, but our epicyclic part is this part here. We are referring to this part. This is the epicyclic part that we are going to work with. All right, so let us just understand our components. Remember, our components said you have got the arm, which is E. In this case here is representing the arm. Then the outer part of our gear is the ring gear, or the annulus in this case. So here we are referring to the annulus, which is our B. Then we have got the D here representing our sun. This is the sun gear in this case, and the planetary at EC. This is our planetary gear. All right, so the question is, in the epicyclic trend shown in Fig 2, so we have got this part. We are given the number of teeth on each part that we have here. So we are given, let us take note, if it shows gear B, which is the annulus in this case, it has got 120 teeth in this case. We've got 120 teeth in this case. Let me just use T for teeth. All right, 120 teeth for B. Then externally, so it has this externally and 100 internally. So here there is an internal part. This internal, this one is the one that is inside, internal. Then external, the outer part that is in contact with A. So the external is in contact with A, whilst the internal is in contact with the planetary. In this case, the internal is the one that is in contact with the planetary. The external is in contact with the gear A. All right, so in this case, we said we've got 100 teeth internally. So this is for internal. Driver A with 24 teeth. So this A here, it has got 24 teeth. And arm E, the arm in this case is connected to the driven shaft. All right, the arm here is connected to the driven shaft, and gear D has got 40 teeth. Remember, D we said is the sun gear here. We have got 40 teeth in this case. All right, so here there is 40 teeth. So we do not have, if we are to check here, we do not have the number of teeth of the planetary gear. That is the only part that we do not have, but others we have. Here we are given the speeds. All right, the speed of A, the speed of D. So the first question was to calculate the following: the number of teeth in gear C, the number of teeth in gear C in this case. All right, what is going to be the number of teeth in gear C? If we are to consider, I want us to be careful here. Let us consider where we have our C. All right, let me just try to reduce, since we have our diagram, we have seen our diagram here. So let me put it this way. So if we are to consider properly what we have on C in this case, it's our planetary gear. And for the number of teeth, we do not need any special table or any special calculation there. We need to know, remember the idea of the number of teeth on the annular, because we are talking about the planetary, given the sun gear, given the annulus. So we know that, all right, 8.21. We understand that the number of teeth on the annulus is equal to the number of teeth on the sun gear plus 2 times the number of teeth on the planetary gear. This is a formula that you are given on your formula sheet. You have this formula. We are considering here the planetary gear, which is the gear C. So let us write in terms of this part that we are given. So TA, which is the annulus, A is for the annulus. Our annulus in this case is the gear B. This is our annulus, the gear B. So meaning we are saying TB is equal to TS, the sun gear. The sun in this case is our gear D. So it's going to be TD plus 2 times the planetary gear. The planetary is C, which is our C. So we can calculate the number of teeth on gear C. That is the condition there. We can make this the subject. All right, so let us make TC the subject, transpose TD to this side. So it's going to be TB minus TD, which is equal to 2TC. So to find TC, we can simply divide by 2 both sides. So that means we are remaining with the number of teeth on gear C, which is going to be TB minus TD, everything over 2. So the question now that we have is on B, because on B here, which is our annulus, there are 2 conditions. We have got the 120 teeth that is external. Remember from our part here, 120, which is external, and 100, which is internal. So if we are to talk about this B, how is it affecting? This is our condition now. We are asking ourselves, how is it affecting C? How is it affecting C? B, how is it affecting C? It's affecting C internally, inside. It's affecting this inside. A is the one that is affected external, outside. So meaning to say we are going to consider the inner part of what? Of B. It's affecting inside the C. It's affected this planetary part. It's affected by B, which is the annulus, internally, inside. So we are going to use the number of teeth which are in the inside, the interior. Internally means inside, internal, inside. So meaning to say we are going to take 100. The one that is affecting C is the internal part, the one that is inside. So please take note about that. So it's going to be 100 minus TD, which is our TD here. The number of teeth on the sun gear, it's 40. So it's 100 minus 40 over 2. So this is going to give us the number of teeth on gear C. All right, so that is you with your calculator. In this case, as we can take notice, 100 minus 40, which is 60 over 2, which is going to give us 30 teeth in this case. So we have got 30 teeth in this case. These are the number of teeth that we have on what? On our gear C, which is in this case is representing the what? The planetary gear. All right, so that was the first part, 2 marks for that. And we move on to question 8.22, whereby we are now asked to calculate the speed of arm E, the speed, 7 marks. Whenever you're dealing with the speed now of the arm, we are supposed to consider the table there. We are supposed to consider now our table. But if we are to take note on our table, this part here, A is not part of the table. We are dealing with epicyclic. This part, like I described this one, this is the one that you're going to use on your table. So if we are to take note on our table, let us just take some of the information that we have so that we can have our table here. We are given, that's 8.22. Given the information here, we have got on gear A, we've got the speed on gear A, which is 125 reps per minute, 125 revs per minute. We also have gear D, the speed on gear D, which is 300, that is 30. All right, that is 30, sorry. So this is 30 revs per minute. And we also have the number of teeth, like what we talked about before. And we talked about this. If you were to consider on our table, remember the concept of the table, we are going to consider these gears. We are going to consider gear B, which is the annulus, the arm, the sun, and the planetary. Not A. A is not involved on this part. So if we are to check here, we do not have the speed of the annulus, the speed, how is it rotating? We only know how is A rotating, which is A, remember, is just an part of just an external gear that we have. Then we've got D, which is our sun gear. We have got its speed here, this one. This D, we are given the sun gear, we have its speed. So what can we do now to calculate the speed that is affected B, since we do not have B? So let us just talk about the B, the speed on B, because before we talk about the table, what is going to be the speed on B? Our question, yes, it is asking us to calculate the speed of the arm, of which the arm is given as E. The arm in this case, it's what? It's E. So we need the speed of arm E in this case, which is true. But on the table, we need also the speed of this B on our calculation. So where are we going to get the speed on B? That's where we go back to the external part now. B, it's linking directly, externally here. We have got a rotation that is happening here. As B is going this side, meaning to say A, it's opposing the other way. So what is going to happen here? We are going to affect A externally. It's affected external. I said internally, it's affecting C, the planetary. So on the external part, B is linked together with the A. These two, they are linked together, but externally. So meaning to say, from the ratio of speed and the number of teeth, we understand, remember, we are dealing with B and A. So it follows that the number of speed on B times the teeth on B is also equal to the number of teeth on A times the teeth on A. The number of teeth, we are focusing with the B, the ones that are linking here. There's a linkage that is happening between B and A. B and A. But externally, whilst B and C, which is the planetary, internally, it's affected internally. So meaning to say, that's where we are going to use the number of teeth here for the external on B. We are given the external number of teeth of 120. So we are going to have here, remember, I want the speed on B. So you can make this the subject. You can divide by NB. All right, we need the speed, so you can divide by TB. Sorry for that, guys. Divide by TB, both sides, so this is gonna cancel. That means the number of teeth on B, the speed on B is going to be the speed on A, whereby the speed on A we have here, okay, we wrote it 125. So it's gonna be 125 times the number of teeth on A. The number of teeth on A, remember we listed this before. On A, they have 24 teeth here. It's also given driver A 24 teeth. So it's gonna be 24 over now the number of teeth on B. That is where we are focusing with the external, since these two are connected externally to each other. So we are going to use 120. Please be careful on these two, how they are given. So we are going to use 120. That's the number, that's the speed that is going to affect B in revs per minute, is going to give us 25 revs per minute. And this one, let's consider also the direction, because we need the direction there. We need the direction. All right, what is going to happen here as these two are rotating? As these two are rotating, we are going to see that as A is going to rotate, whereas we are considering A, if A becomes the driver in this case, we are going to see A going in the clockwise. We are going to see it happening this way. We are going to have A going in the clockwise. All right. The moment A is going to go in the clockwise, meaning to say B at that moment is going to be in the anti-clockwise, it's going to be affected with a negative. All right. If this B is going in the clockwise, it means A is going to be anti-clockwise. So this value is going to be a negative at the end, since it's going to be an anti-clockwise rotation. So we are going to have this as a negative. All right. As our B, all right, here as said, the speed on A is going to be affected in the negative way. Even if this was positive, all right, this was going to be anti-clockwise. So meaning to say on the A here, we are going to have a negative. So it will be negative, negative here. So it's going to be a negative, and our answer becomes a negative also. So we are simply saying it's 25 revs per minute anti-clockwise. Remember, a negative is anti-clockwise, anti-clockwise. So that is going to happen. We are going to have a negative in this case. That means 25 revs per minute. This is the speed on B. This is not part of our question. The question needs us to calculate the speed that is affecting E. So the only part that A is going to play a role was to find the speed on B. This is the only part that you're going to use A. Now to find the speed on E, we are back now to the table. Remember our table that we use on our calculations now to calculate whatever speed. So I'm going to have my table here. Let me try to have my table so that we can use it for our calculations. So here I'm just going to have maybe just about 3. Just let us consider 4. Remember, we have got the first part of the conditions and so forth. Or let me just draw there now, explain this one later on. All right, so like I was saying here, we shall have the number. So let us just say here we have got our number. Then we have got the condition. All right, so here we're gonna have our condition. Then let's consider our gears in this case. So what we are simply going to do, like I was saying, A just helped us for calculations, but on our consideration, we consider our epicyclic, meaning to say we need the planetary, the sun gear, the arm, and the annulus. These are the only that we have. So I'm just going to start from the annulus, the external part, and so on and so on. All right, so let us have here, we shall have our gear. B, remember the annulus was gear B in this case. All right, so our gear B, which was the annulus in this case. Then we have got our gear C and also the gear D. So we also have gear D and the arm. So that is the arm E. This is what we have. This is the part of the epicyclic gear, not the gear A. A is an external part that we are not even considering, just for the calculation of the speed. That's where we could have considered that. And remembering, I listed this before. I said C is the planetary in this case. That's our planetary. This is the sun in this case. All right. So remember, on your table, this is something that is fixed. This information here that we have about the speed and so forth to say this one is fixed and so forth. We are not considering this for now. The first step after having your table here is always the first condition is to fix the arm. The arm is supposed to be fixed. This is what you're supposed to have. If you check the introduction part of our video from our N4 part, we have to fix the arm. So here we are going to fix the arm, which is our arm in this case is what? It's E. So we're going to fix the arm E. Then we rotate the bigger one, the largest gear wheel. And our largest gear wheel definitely is what? Is the annulus, which is the ring gear. So you rotate the annulus 1 revolution clockwise, meaning to say it's supposed to be a positive. So you're going to rotate this part here, our annulus, the inner part is the one that is rotated, not the external. We are dealing with the inner part of this. Remember, the external only affects the part of what? The part of this A, which is connected external. This planetary is connected internally to the what? To the annulus. So we are going to consider this in a clockwise rotation. So this is the condition. The largest gear wheel is the one that you rotate. So this first condition, it's a fixed part that you're going to have on each and every question that you're going to have. You fix the arm, then you rotate the largest gear wheel, and our largest gear wheel is the annulus. So we are going to rotate B in this case. We are going to rotate gear B, which is the annulus in this case. So this gear B is simply representing the annulus or the ring gear plus 1 revolution. So plus 1 revolution means 360 degrees in this case to the what? To the right. It's a clockwise. All right, we are going in a clockwise. So that is your first condition. Now let's consider our gears. What is going to happen to B? Gear B is the one that is rotated. Remember, we are saying we have to rotate the larger part, which is gear one revolution. So already gear B has rotated. It has rotated what? 1 revolution. So that one is just going to be a +1. So we have got a +1 revolution there. What about gear C, which is our planetary? Let's see what is happening with what? With the C. What is going to affect C? All right, at C, this is where we have at the planetary here. This is our C. So if we check what is happening at C, we are going to see that as the planetary is going to the clockwise in this case, as this planetary, as this annulus in this case, which is the ring here, is going in a clockwise, we are going to have a same condition going in the clockwise because it is being opposed. In this case, it's being opposed by the sun gear. The sun gear is the one that is opposing in an anti-clockwise, whereas the planetary is going in the clockwise. So the planetary is going to be in the clockwise. So meaning to say we have got a clockwise. Remember the driven over the driver in this case. So we're going to have the annulus over the planetary. And also on your table, I explained what's going to happen. Is we are going to have what? TB over TC in this case. So this one is going to be TB over TC, which is both in a clockwise. So remember the number, the teeth there for B, we are dealing with the one that is inside, which is the internal part. The internal part is the one that is affecting the planetary, and B internally it's a 100. Remember, it's 100 teeth internally. So it's going to be 100 in this case. So this will be positive 100 over TC. On C, how many do we have? C, we calculated it in the first place here. TC, we got 30. So it's going to be 100 over 30. All right, so that's it. You simplify. You are going to obtain something like 3,333. All right, then we move on to D. What is happening now on B, which is the sun gear? So the sun now is affected from the inner part. Let's check where we have our sun gear. The one that is in the inner part. So it's affected from the outer part. So we are going to start first with what is happening on the outer part. Remember, on the outer part, we said we are going to have TB over TC. On the outer part, we are going to have TB over TC. That is what we have on the outer part times internally. Now, how is this affected internally? Oh, I mean inside, the way it is inside, it's affected by the planetary, which is going clockwise, and this sun gear is going anti-clockwise. So it's going to be TP, which is the driven. So it's going to be T planetary, which is TC. So it's going to be TC over the driver, which is now the sun. So the sun is going anti-clockwise. So it's going to be minus. The sun is the one that is represented by what? By D. So it's going to be minus TD like this. So meaning to say it's going anti-clockwise. So it's going to be carrying a negative on that part. So this is the formula that we are going to use or to have. TB times, of which if you check on the, it's just, you see that these will cancel TC, TC. If that connection is not happening, that connection there is not happening, you see that somehow there's an error there. So you have to be careful also on that part. So here we are going to have TB over TC times TC over minus TD. All right. And also on the introduction, the formula there is there, but if you can get it back from the diagram, still it's fine. So it's over minus TD. So simply means here we are simply needing TB and this, because this one and this one cancels, or you just take this one as it was before. It's still one and the same thing, because you have got 3,3,3,3 times whatever that you're going to have on what, on TC over TD. It's one and the same thing. Or you are just dividing these two, because this one and this one will cancel. So you're going to remain with TB over minus TD. And remember, TB before it was 100. So it's going to be 100 over minus TD. So it's going to be minus TD. On D, how many do we have on D? All right, remember on T here, it's 40. All right, we said it's 40 on D, so it's going to be a negative 40 here. All right, sorry for that. So we are going to have a negative 40. So that's it. Or here on that answer, you multiply this, you're going to obtain the same thing. So we are going to obtain negative 2,5 in this case. So this is going to be negative 2,5. So that's how you affect this. You are considering what is happening here. We are rotating B. So what is going to happen to D? It's going back to B, B. It must start at B, start from the previous condition to the next condition. What about the arm at that moment? The arm is fixed. You remember we said fix the arm. So there's no movement. It's fixed there. So it's just a zero. It's going nowhere. It's fixed. If something is fixed, it means there's no movement there. There is no movement at all. All right, so that is our condition. The next step that you're going to take, remember, this one does not change from our N4. We said we are going to multiply by X and add Y. So here we are going to multiply by X and add Y. Then you add Y. Where are you multiplying by X? From what we got previously here, this part that we have, we are going to multiply each by X, then we add Y. So here it's 1 times X, it's like this, 1 times X, whatever that you get, you add Y. So it's gonna be X plus Y. So that is the idea. So this is gonna be X plus Y. The same, this part here, you multiply this by X. So it's gonna be 3,333X. Then you add Y. All right, so that is the whole condition, 3,333X plus Y. You do the same, you multiply this value by X minus 2,5X plus Y. The same, you multiply this value by X, so it is 0 times X plus Y. So 0 times X, that's a 0 plus Y, meaning to say you're going to remain with a Y there. All right, you're done. The third part and the fourth part, wherever there that you're going, that is where now you go back to the information that you are given before, to the information that you're given before. So I want us to consider this part here. I want us to consider this part that we have before. We are given the speeds. So in this case, we're going to work with two conditions. The first condition that we've got these speeds as they are, all right? The A we are not considering because it's external, it's not part of our diagram. So here we are going to take the D. We have got the speed of D, which is 30. Remember, we want to calculate the speed at E. So we do not know the speed that is affecting E. So let me put it this way. I do not know the speed that is affecting E. That is the one that I want to calculate. Given the speed on D, and also given the speed on B, let's say these ones, all of them are there, they are given. All right, all of them, they are given. we have these ones. B, remember B here, it's negative 25. We got a negative 25. So this is gonna be negative 25 revs per minute. We also have for D, that was there before. For D, where is our D here? Where is our D? Our D, it's 30 revs per minute. This one that we are given, it revolves at 30 revs per minute. So we also have the one for D. So this is what we're gonna have here for D. It's gonna be 30. We said 30 revs per minute. All right. So now, meaning to say here, B is the one that we are given. We said B is minus 25. So this is going to be a negative 25 under B. C, what is going to happen with C? We do not have any information about the planetary in this case. All right, so that is nothing. D is 30 revs per minute. So D is 30 revs per minute. Then the speed on E is the one that we are supposed to calculate. So we do not know the speed on E. So using this information alone, we can calculate the speed on E on this condition. And also to take note, let's say we're to consider the issue of torque and so on. We shall talk about that part. You can consider to say, I do not know the speed at E, which is our condition. We do not know the speed that is occurring at E. And let's consider to say D is fixed. If D is fixed at that moment, if there is no movement at D, it means D is going to be a 0. While B is still having its movement or is still having its answer, which is at what? At negative 25. It can happen like that. It can happen like that. So this will be on a condition now whereby you are dealing with what? With the torque now, where we are dealing, calculating the output on the torque. So meaning to say we shall consider this part here when we are calculating the torque, all right? So we shall talk about this part here. We shall have this in our videos, all right? So when you are to calculate the output torque, that will be the condition. I think with this information, we have a class that is separated from this one, whereby I'll explain that part that I was having at the later stage. You understand me properly. All right. So now, with this information that we have, this is the full information that we have about this here. So we can formulate our equations. Remember, our equations is going to be these two corresponding to each other. They are equal. So meaning to say this x plus y is equal to minus 25. We have formulated an equation there. The same thing here, we are supposed to formulate an equation, but this does not correspond to anything. There's nothing about C, I mean, there's nothing here, so we are not going to use anything. Then we correspond these two, they are equal also. So meaning to say we are going to form an equation there. So you consider each and every part that you are given. So here I'm going to consider this equal, all right? So I'm having negative 2,5x plus y being equal to 30. And the last stage here, y is equal to NE, which is the one that we are supposed to calculate. So y is equal to NE. So that is the idea. So that is the whole part of our item 2 in this case, this one, to calculate. So take note, we needed to have the speed for B so that we can use it on our calculation. So that was the use of the external part that we had at A, not to say you are going to consider it. No. You do not consider the epicyclic. These are the components of the epicyclic. These are the ones that you need. The first stage, it's a fixed part. Please check the introduction. This one, a fixed part. Also, this one, it's fixed. You always multiply by X, you add Y. The only condition now that you consider is this one. This is the one that you consider according to what you are given, the speeds that you are given, you just substitute them as they are given, all right? If something is fixed, sometimes they will tell you there's something that is fixed. Everything that is fixed is represented by a 0. So now you've got your equations that you have formulated from this table. you can solve for y because we are saying the speed that is affecting the arm E in this case is y. So we are simply going to calculate the value of y depending with your method. Are you going to use elimination method? Are you going to use, I don't know the method you're going to use. So in this case, I can just make x the subject here so that it's gonna, I'll be left with y. If I make x the subject here, let's say this is my equation 1, this is my equation 2 from equation 1. So from equation 1, let us make x the subject. So x is going to be equal to y to this side is going to be a negative. So it's going to be minus 25 minus y. So this is another equation. X is equal to minus 25 minus y. So with this value here, I'm going to substitute this into the second equation. So we substitute in equation 2. So you're going to substitute in equation 2 so that we remove this x and have it in terms of y. So it was minus 2,5x, so it's going to be minus 2,5 times x, which is this x that we have here. So it's going to be minus 25 minus y like this, all right? Then there is a plus y that is already there, this one, plus y. So we're going to have plus y is equal to 30. So as you can see, we are just left with y in this equation. So we can solve for y. By solving for y, we are determining the speed on E because the speed of E, it's a y there. It's not a positive, but we shall see the answer there. So expand the brackets. That's this one and this one multiplied is going to be 62,5. Negative 2,5 times positive times negative y is going to be a positive 2,5 y in this case. Then here there is a plus y, which is going to be equal to 30. Collecting of like terms, that's 2,5 y plus 1 y is going to be 3,5 y, which is equal to, transpose this to the right hand side so it can be a negative. So you're going to have negative 2,5 on negative 62,5. So if we subtract, we are going to obtain negative 32,5. Divide by 3,5 so that we have the value of y in this case. So that means y is going to be what? All right, so y is going to be a negative. That's the first thing that we can see here. So we are going to have negative 9,286. So this is the value of y representing what? The speed of E of the arm. So therefore, the speed of arm E in this case is going to be negative 9,286 revs per minute, or we are simply saying 9,286 revs per minute anti-clockwise. If you write in words, anti-clockwise like this, and negative means you are going in the anti-clockwise. So like I said, if it was a condition whereby you're supposed to calculate the torque now, then you have to extend your table. We shall see that on another video so that we can work it as a separate, but make sure that you watch the introduction part so that you just understand the formulas, how are we rotating this and that. It can be very, very important, and also to check from your N4 stuff, because some of these calculations are simply an extension that we are taking from our N4, and also your formulas like this part, the calculation of the number of teeth on gear B, the calculation of the number of teeth if we are given the number of teeth on the annulus, the number of teeth on the sun gear, and also the number of teeth on the planetary. We can use this formula. It's there on your formula sheet. So that is what you need. So let us revise as much questions as we can. But for now, that's it till we meet again.